The commissioning process is really intended to kind of get everyone on the same page so we can kind of collaboratively move forward, getting the good ideas from everybody at the table, because regardless of the number of years of experience I have or an architect has, there's potentially a better way to perform that detail, and the subcontractors and the GCs often have a lot of great ideas, and we want to hear those ideas if they really can bring value to the process. So it's not just a kind of authoritative approach. So we move into the construction phase. A lot of people don't talk about safety in the context of commissioning, but I think given that we're working on the building enclosure, I really like to think I'm joining the club here and saying that safety is number one. We've had the experience, I've personally had the experience of knowing someone that didn't come home one night, and that's not anything I want to share with anybody else. So commissioning, the team that we work with every day, safety is absolutely critical. So following whatever the contractor's process is, whatever the subcontractor's requirements are, we are, my company is very aware of our safety, the safety and the risks that we put ourselves in every day in dealing with being on the outsides of buildings, being on the roof, being on the scaffold. And I think I can't overstate how important that is, not only for the process of construction, but also for how the owners maintain their buildings. And I think that's an important aspect that the architects need to address, and that the commissioning process needs to include as well, is how can the owners safely maintain their building. So put davits, put fall protection systems in, put safety lines in, make it easy to be safe on your projects and maintain them. So aside from our everyday safety awareness, on the job site, we're out there periodically. Now, I like to describe it as milestones because I don't think there's actually a routine, like once a week types of things. Construction is too ebb and flow kind of process. So we really need to be flexible, and you need to kind of build that into your budget as a commissioning authority, is to say, all right, I realize that there's going to be a little bit of a up, down, a slow down, and to make sure that you understand that and be flexible in your observations. Review mock-ups, checklists, coordinate with the general contractor's quality control. Remember, you are a team and you can't give direction. You can walk with the GC's QC team, talk to them about what's going on, but you can't actually tell them, change that flash and do this, do that type of thing. But hopefully through this they become more aware and understand more about really kind of where you're going and what the real performance critical issues are. There may be an opportunity or a need to develop some kind of sketches. We're always coming up with things that we didn't expect. So you can help out the process, you can do some hand sketches, modeling, whatever might help out in order to give the architect some ideas about how to solve these types of problems. Typically we're going to have coordination meetings for the commissioning process every couple of weeks, and we want everyone attending, especially the subcontractors. And then we coordinate, observe the field testing, and that can be varied types of field testing depending upon the requirements of the building. So I'm going to talk specifically here about some waterproofing. And this project was with George D, so I have chosen those guys specifically. So hopefully they can both enjoy the reflections and share the pain.
Oh, Jesus.
It was actually in this room that we first did one of the mock-ups.
We mocked that thing up 20 times.
We did. And you know what? It doesn't leak. So, so one of the early ideas from commissioning, and I think this just kind of extends beyond commissioning, but it's just a good thing to do, is a mock-up. And so gives the ability for the contractor to coordinate the work, understanding how the sequencing and all such things are going to come together. And the subcontractor gets a better understanding of methods to implement, train his personnel perhaps, and ultimately just try and get it right the first time in the field, that is. So this was a complex expansion joint in a tunnel that was 5 feet below the water table. So we have a typical challenge of expansion joints in below grade waterproofing is you don't actually have a manufacturer that does it all. You don't have a single source to go to. So you're always challenged by the expansion joint material itself being, adhering and compatible with the waterproofing membrane that you're actually choosing to use as your primary kind of bathtub waterproofing. So this was in Dallas, which I've now become to appreciate all of the expensive soil issues associated with waterproofing, which was a new challenge for me moving here. So we have the void forms, which we replicated. We have a high-density polyethylene membrane and essentially a rubberized expansion joint material, where these two flanges here are the ones that engage the waterproofing material, and this black bellows in the center here, which allows for the actual movement. So the first thing we did was we actually laid the membrane out in this room and just kind of did some basic, because first thought I think was you were going to install the expansion joint in the shop here and then take it to the job site.
Right.
Yeah, and then that ended up being a little bit too cumbersome because this material was so stiff that you couldn't actually move it once you got it stuck.
Yeah, when you moved it, you had a breach.
Mm-hmm. So you rolled it up and it kind of separated and we defeated the purpose. So so we went away with that idea. So then you decided this was actually one that was done in the field, but we had one in the shop out back there where the membrane was just laid out on the two sides, and the idea was how can we make this profile here, because essentially they had a grade beam that sat on top of the pile,
Pure cap?
Pure
cap?
Pilers? Yeah, the pure cap, yeah. And so we had to extend, that's why we had this funky profile. We couldn't just make a right angle out of it. Actually had to follow the profile of the grade beam. So it was a challenge making all these corners. It was a challenge, first was getting the material to actually stick. We went through some challenges with the two-part membrane because it was a mixing concern. And then we were challenged by how we're going to test this thing. So there was ideas about putting it in a bathtub, essentially. So that's what this concept was about, because we really wanted to make sure that we got, there's only one chance to do below grade waterproofing, unfortunately. So one of the concepts was how can we test it? Once we've got it installed, how do we really test it? So we actually put the membrane installed, supported it on buckets underneath, weighted it on each side, and filled it up with water. And that was the method that we used in the shop to finally test and successfully pass that water test. So it was a long process, but I think it was a very valuable process to understand exactly what the challenges of that material ultimately were. Now, we were further challenged when it became 100 degrees because the guy's boots actually stuck to this material. So they pulled off the adhesive that's intended to bond the high-density polyethylene to the concrete. They walked it home with them. So it was a multitude of challenges. So out of that process, you and both review of shop drawings and mock-ups, you get a lot of information. And out of that those reviews and that work, the concept is to develop some checklists. Those checklists can be used by the subcontractors in the field, and they should be daily or weekly, whatever that process is, reviewing the items that are identified as critical and essentially notating that those issues have been reviewed in the field and checked off. So there's a level of responsibility, there's a level of engagement. Now sure, the guy can just come in and check, but that's where the general contractor QC team comes into play, and that's where the commissioning provider comes into play. It's their responsibility to review that those checklists are actually being completed appropriately, and it's not just a guy kind of coming through and rubber stamping, it's everything. So we're reviewing the checklists and kind of making sure that there's a collaborative environment working between us all.
This process, by the way, actually benefits more than this job. So you go through a commissioning job that's very thoroughly administered, and you go to your next job, and that level of detail and that level of attention is still there. You can't let that go away. So you learn all these really neat things about how to be really good at what you do, because Fiona's going to be out there tearing it up, telling you to redo it. So you get really good at those details, and the next job you go to, you're carrying that same level of detail, even though it's not a commission job.
Yeah, no, one of the girls that works for me came back into the office just the other day and said to me that she's super happy with the project she's working on right now. It's the same crew from George D. She's got the responsibility to do all the construction observation. And she said, you know what, I won't use names, but he said the foreman came and shook my hand. She said I congratulated them, they did a really good job. I could tell that they were really working hard to get this detail correct. They did it a couple of times. They worked really hard. They were able to repeat that continuously, and he was so proud of himself. He came. He shook my hand, and they had a moment.
He loves that.
But I think you're right. It goes both ways. If you can, it's certainly a pleasure to work with folks that take a lot of pride in what they do.
Now he has a heart condition because of that.
So we understand the challenges of below-grade waterproofing. I've been in enough pits and got muddy and dirty enough to understand that it's not an easy environment to work in. But we're all there for the same purpose. Nobody wants to come back to any of these projects and kind of witness the types of injections, efflorescence, and ponding of water that we saw earlier in that garage. So there's the visual observations, but there's also some planning that's really smart. It's understanding the waterproofing system that you're actually working with. So if you're working with a bentonite system, you've got to understand the limitations of that system. You've got to understand you can't just have standing water, kind of running around. I had another photo of this project 1 year later with a pool of water over the entire basement. It's not here, it's in Washington, D.C., where we built that city on a swamp, so everyone expects to get water in their basement. But it didn't help by the fact that they didn't take care in preventing the pre-activation of the bentonite system. So there are challenges. There's not a lot of ways that you can really test below-grade waterproofing. Some methane, some smoke, some air infiltration. It's a little bit challenging. But their visual observations becomes really, really important. So working closely with the quality control team, because those are the guys that really are ultimately responsible, and they're the ones that have the relationships with the subcontractors. So substrate reviews, some few things that are really critical to waterproofing is your substrate prep. How well is your concrete consolidated? What kind of primer might be used when they strip the forms. One of our challenges is recently on this project where we had a number of air pockets. Once they pulled the concrete forms, the concrete itself had little baby pockets, and there was a very thin slurry over the face of these pockets, so it actually appeared like it was a fairly well uniform kind of concrete pour. But once you actually started to, even just with thumb pressure, push on these little holes, they all of a sudden popped. Now, we found this out the hard way because we sprayed a fluid applied waterproofing over the top of it. So all of these little kind of air pockets right here actually started to blow bubbles. We've got warm air in there, and as the sun heats up, we've got air inside. As the sun hits the wall, the air heats up and wants to expand and blows a little bubble on the outside of the waterproofing. So this waterproofing was just little bubbles everywhere. So we kind of did some multiple investigations and realized that the substrate was really not as well compacted as what we first understood it to be. So their contractor, much to Dan's distress, had to come back and I think he sandblasted the walls, right?
Yeah, we had to sandblast to open up the holes and the slurry of the filament.
Yeah, and so that was coordination of trades, recognition that there wasn't really a tight concrete spec on what the finish needed to be, which could have helped out the waterproofer. So, lesson learned. What are the materials? Are they compatible? How am I going to marry? What are the temperature requirements? All of these kinds of issues that come into affecting the performance of the systems. How do we apply the membranes? What's the detailing? One of these specific details that we really challenged us here, you may not be able to see this, but there's the pile cap here, right here. So we've got the rebar, number 8 or whatever, coming out of the pile cap. And the waterproofing structurally was not allowed to impede on the concrete-to-concrete bond between the top of the pile cap and this grade beam that we had running here perpendicular. So the waterproofing was able to come up to the sides, but was not allowed to actually come to the top of it. So we're thinking, boy, that's a nice breach in our waterproofing system. But we were able to kind of develop a detail like a flower, and boy, we mocked that up a number of times as well. So the membrane wrapped around the circumference of here, and then basically kind of petaled, if you will, out to integrate with the primary base waterproofing here. But there was, you're not the only guys in the field. You put your waterproofing down, and then you get a whole lot of rebar guys trading, piercing and everything on top of your membrane. So again, another layer of visual observation and potentially repair is necessary. So it's really hard to test that kind of stuff, just prior to your concrete pour. And then the placement of the concrete, the formwork, you've got more challenges. The guys love to drive nails through your material, and then the placement of the concrete itself. How is it placed? Is it going to potentially damage your waterproofing system? On this project here, as I say, it was a tunnel. We used the fluid-applied waterproofing system with the high-density polyethylene blind side, if you will, as the bottom of the tunnel. We used a high voltage testing for this system. Now, you're familiar with the low voltage and the high voltage. This concept essentially uses a steel or a brass broom. This is the smaller version of the broom, a wand, but there's also a version about 2 foot wide. And you connect yourself, so you've got a device here that provides audio feedback and a ground that takes you over to, whether it be a drain, or in this instance we grounded to the rebar that happened to be exposed at the top of this wall. So the concept is, if you find a breach in that membrane, the circuit is completed, and you will identify that hole, if you will. So you've got electricity coming through the brush, running over the surface. It's acting as an isolator. If you come across a breach, it's going to complete the circuit because it's high voltage. Same concept actually for low voltage, and it will complete the circuit and then give you an audio beep to alert you to a breach at that location. So unlike the low voltage, which you can't use on vertical walls, the high voltage worked out quite well, and we did it in sequence with the placement of the waterproofing as they kind of backfilled the system. Low voltage, just to kind of be complete here, similar concept, it just uses a wet substrate, whereas the high voltage, you don't want it to be wet. That can hurt. And then the basic version of our flood testing, we've got to make sure you understand exactly what you're testing. Sometimes if you're, like, I couldn't apply the high voltage or the low voltage over this composite membrane system because this composite is not actually integral to the waterproofing. It's just kind of like a protection board. It's broomed in place. So although it adds protection, it's not, and they say it's a waterproofing layer, it's not the waterproofing layer. So water test was the most appropriate use here. If we've got a sloped deck, we understand that we need to build dams in order to kind of make sure that we sequence our water testing. And then if we've got vertical surfaces, one of the limitations of the water test is that we don't test vertical surfaces. So don't be limited, apply a project-specific testing matrix or schedule, and make sure that you use a nozzle or you use a hose in different ways to actually test all of your conditions. So many of our projects these days rely upon adhesion solely, so we can use the alcometer to verify adhesion, so pull-off resistance. This testing equipment is typically used on air barriers, but I think it can be quite appropriately adapted for use on waterproofing systems. Here we're testing, so you've got basically this suction cup inducing a negative pressure. It's looking for a hole in the splice on these membranes. So before you push this suction cup down, you apply a little bit of surfactant, so dishwashing liquid, if you will, in the soapy water, over the surface that you're actually testing where you may suspect a breach. Pull it in a negative pressure. If you get a little bubble, like you do here, then you understand that you've got a breach. And just wrapping up, the occupancy phase of the commissioning process is critical, kind of closes the book on the entire process. It provides the owner with a closeout report, a report on how to maintain their building, and then ideally you are to walk and talk and educate the owner of the building as to all of the different aspects of how the enclosure is constructed and ultimately how they will maintain it. So this maintenance manual provides them a record of who did what the materials were, what the colors were, for example, so that they have issues in the future, they know exactly who to contact as well as the commissioning authority. So concept is for commissioning is plan ahead and you'll be able to meet the owner's performance requirements and objectives, and I will be able to provide the presentation for you. And if you're interested, there's 3 great websites: the Whole Building Design Guide, Beck National, if you're not involved with your local Beck. I highly encourage that. For in Beck Dallas, they meet like once a month down at AIA. And Building Closure Commissioning Collaborative, where we're developing resources for the commissioning industry available at no cost, or if you want to become a member, then there's that option. So, thank you.